we are going to see about the Horspool algorithm. So now the idea of Horspool algorithm is to create a table that is called the shift table, and once we do the shift table, I can easily do the pattern matching. We will discuss the we will discuss the overall idea of the algorithm, and then we will move on to the code. So first of all, I create the bad shift for the pattern, the shift table for the pattern, CABD. So CABD, here D gets its position 4, which is the length of the pattern, and how many positions is B from the pattern? B is 1 position. A is 2 positions from D. C is 3 positions from D. So this is what we should do. We should check how many positions is it from the last character, except the last character. The last character will get the length of the pattern. So that is step number 1, where we create the shift table. Now we move on to the next step, which is the main part of the algorithm. And once we create the table, we initially check with these first 4 characters with the 4 characters over here. This is not matching. The last character here is C. What is the number pertaining to C? In the shift table, it is 3. So now I am going to move ahead by 3 positions. So here, when I move ahead by 3 positions, I will get comparison with CAAB. Now B is the last character, 1. 1 is the number pertaining to it. So now I have to move ahead only by 1 position. So here it will check, but it is not matching. So A's number is 2. So I have to move ahead by 2 characters. So now I move ahead by BADC. Again C means I should move ahead by 3 characters. So I move ahead by 3 characters and I will get CABD. Because there is a match, it will check that there is a match, and that value is going to be returned to the algorithm. Otherwise, a -1 is going to be returned. This is the idea of the Horspool algorithm. So first of all, we create a shift table. In the shift, this is the shift table. The last the last element's position will be same as the length of the pattern, and then all the others will get how many distance are they away from the last element. So B is 1 distance away, as we can see. A is 2 distance away, and C is 3 distance away. Once we do that, we check for the element, and so we check the first 4 characters here with the first 4 characters. Now here the last character is C. C's number here, shift table, is 3. So I move ahead by 3 positions. So A, B, A I do not consider, and I move to this. The next number is B. B's is 1. So I move ahead by 1 position, and I will compare this. The next is A. A means I move ahead by 2 positions, and so I compare BADC. The next is C. C means I move ahead by 3 positions, and so I will get here comparison of CABD, which is the same as the pattern, and so it will return me the location of this. It will give me this particular location, indicating the pattern where it is available. So this is the whole idea of the Horspool algorithm. So initially I'll create a table which is the same as the length of the pattern, and then I will check, I'll update it to indicate how much are they differing from the end of the pattern. Then here, so in the Horspool algorithm, I first of all create the shift table, then I keep traversing the loop till the end of the pattern, and here I am checking for the number of elements that I'm checking here now this is a right to left comparison where I check the lightmost element first, and then I check the uh, left element. So as you can see here, D, B, A, C will get compared, and then it is giving me 9 as the position. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 is the position where the element is occurring. So this particular step is going to check the element by element with starting from the last element. Once it comes out of the loop, it will check if there was actually a match. If there was a match, it will return the appropriate value. Otherwise, it is going to move the I value to it will check against the shift table. Now from the shift table, it will check what is the last character value and what is the value that it will get. It will increment by those many values. So I will get incremented from those many values, and here again it will start comparing with I minus k again. So every time I want to compare again, k is reset to 0, and again it will start comparing from the end of the pattern. If it sees a mismatch, immediately it will go and update the pattern to search for.